Hi there and welcome back. It's Mr. Rootside here again, and we're looking at graphing in our physics section. And we had a number of videos that I did on graphing up to this point in time. The last one was on velocity versus time graphs, basically making it and converting a position versus time graph to a velocity versus time graph. You might want to have a look at that one. But now what I'd like to show you guys is the information that we can obtain from a velocity versus time graph. So what does a velocity versus time graph tell us? Okay, and if I put a line on this, and I know that in our last one, I'll make this orange. In our last one, we were looking at, we only had flat information or flat lines on our last one. So if we have a line that looks like this, what does it tell us? Well, I know that if we look at the slope of that, the slope of that line we can tell obviously equals 0. So what does that tell us? What information does that tell us? Well, I know that this object is going 5 meters per second for 5 seconds, and it doesn't change its velocity. So it's not speeding up and it's not slowing down. Its slope is 0. So what does the slope of a velocity versus time give us? Time graph give us? Acceleration. Now, how do we know that? Well, with our slope formula. So in simple terms, slope is rise over run. And if I just put in my units, just my units alone, I have meters per second over seconds. Okay, so I have my y over my x value, meters per second over seconds. Now, if I just work out the math, and this is how I'm going to prove to you that this is acceleration. If I just work out the math, I have meters per second over seconds over 1. So again, anytime I had seconds here by itself, I can put any number over 1 and it just equals to itself. Now, when we when I divide by a fraction, I'm going to multiply by its reciprocal. So this gives me meters per second times 1 over seconds, which is the reciprocal of this number here. Okay, and that now equals meters over seconds times seconds, which is meters per second squared, which is a unit of acceleration. Okay, so first thing I need you to understand is that the slope on a velocity versus time graph is equal to acceleration. Okay. All right, the second thing I'd like you to know about the velocity versus time graph, the information gives us, is something known as area under the curve. Okay, and the area under the curve gives us displacement. So how far the object has gone from the beginning to the end of its movement. All right, displacement. Now, it's not going to give us distance, it's going to give us displacement. So, for instance, if I put a line on here, and let's just go, again, we're going to go from 5 meters per second at 5 seconds, for 5 seconds. In order to calculate area, I'm going to look at anything between the line and 0. Okay, so that is, in order to calculate area, I usually go length times width. Okay, so here I have a square, and I'm going to go 5 meters per second, and I'm going to multiply that by 5 seconds. Okay, now I'm going to write that in a little bit of a different way with my units. 5 meters over seconds, and I'm going to multiply that by 5 seconds. So look at what happens. My units for second cancel out, and I end up with 25 meters. So if I travel 5 meters per second for 5 seconds, I'm going to travel 25 meters. Now, what happens when I put that acceleration in there? So let's say I go this way, and I put an acceleration in there. Now I have to calculate, remember, it's everything between 0 and our curve, the area under the curve. So I know that this square here, because we calculated that already, was 25 meters, and I have, if I put a little dotted line across here, I have another equal square. So that means that it's gone 25 meters, and this is another 25 meters. Now I just have to calculate the area here. Now how do I do that? Well, area of a triangle. 1/2 altitude times base, okay, gives me 1/2 times my altitude, which is a total of 5 meters per second. And I'm going to multiply that by my 5 seconds. So again, 5 times, I'm going to divide these out. 5 times 5 is 25 times 1/2, gives me a total of 12.5 meters. So that's this portion here, 12.5 meters. So this object, after 10 seconds going at 5 meters per second for the first 5, then accelerating to 10 meters per second, has traveled a total of 62.5 meters. Okay, so I just add up the area of all of these different portions under the curve. That's the second thing. All right, the final thing that I want you to know about this is probably the easiest of the two, or the easiest of the three. If I put my curve back on there again, it is instantaneous velocity. Okay, instantaneous velocity. So velocity at an instant in time. So if I said, okay, at 5 seconds, how fast is it going? 5 meters per second. That's the easiest thing to do. You just look on the graph. Now I didn't draw a great line here, but all you have to do is pick a point off the graph, measure it over here at a certain time, and you'll be able to tell. Okay, that's instantaneous velocity. So again, just to review, the 3 things that I want you to know is that slope is equal to acceleration, and area under the curve is equal to displacement. Okay, and then of course our line, or our slope, we'll do it this way, our curve represents velocity. Okay, so those are the 3 things that you need to know. Practice these. It's easy to pull the information off of these, and we will see you in class. Science.